Introduction hook. Have you ever wondered how sound travels through the air? Or why you hear an echo in an empty hall? Brief overview. In this video, we'll explore the science behind sound waves, how they work, and why they matter in our daily lives. Preview of topics. We'll cover the basics of sound waves, their properties, how they travel, and some cool real-life applications. 1. What is sound? Definition. Sound is a form of energy that travels through a medium in the form of vibrations or waves. Example. When you pluck a guitar string, it vibrates, creating pressure waves that travel through the air to your ears. Sound versus light. Unlike light, sound needs a medium to travel. That's why there's no sound in space. 2. Types of sound waves. Longitudinal waves. Sound waves are longitudinal waves, meaning the air particles vibrate parallel to the direction of wave motion. Demonstration. Imagine a slinky. When you push and pull one end, the coils move back and forth, just like air molecules in a sound wave. Transverse waves. Comparison. Unlike sound, light waves are transverse, moving up and down rather than back and forth. 3. Properties of sound waves. Frequency and pitch. Frequency is measured in Hz, Hz, and determines the pitch of a sound. Example. A flute produces high-frequency sounds, while a bass drum produces low-frequency sounds. Amplitude and loudness. Amplitude measures how strong a sound wave is. Higher amplitude means louder sound. Example. Whispering has a low amplitude, while shouting has a high amplitude. Wavelength and speed. Wavelength is the distance between two peaks of a sound wave. Speed of sound varies. It travels faster in solids than in air because particles are closer together. 4. How sound travels. Mediums of propagation. Sound needs a medium, like air, water, or metal, to travel. It travels fastest in solids, slower in liquids, and slowest in gases. Real-life example. If you put your ear on a railway track, you can hear an approaching train before it arrives. 5. Reflection, refraction, and absorption of sound. Reflection and echoes. Sound waves can bounce off surfaces, creating echoes. Example. Shouting in an empty room versus a room filled with furniture. More objects absorb sound, reducing echoes. Refraction. Sound changes direction when moving between different mediums. Example. Ever noticed how sound is clearer at night? That's because cooler air bends sound waves downward. Absorption. Soft materials like carpets and curtains absorb sound, reducing noise levels. Conclusion recap. We explored how sound waves work, their properties, and how they travel through different mediums. Final thought. Sound is more than just what we hear, it's an essential part of how we communicate and experience the world. Call to action. If you found this interesting, like, share, and subscribe for more awesome physics content.